Hello. I came into the classroom, remember this place, to make a video to see if I could help clarify what equivalent fractions are. I know you did it on the iReady lesson, and some of you may have gotten it entirely from that, and that's wonderful. I thought I would just present it in a slightly different way, but it is all the same thing. We are all talking about fractions that are equal to each other. So I want you to think, first of all, what does equal even mean? And usually in class, this is where I'd ask you to give me an example of something that was equal or what it meant in your own words. I don't have you here. I know in the past people have told me that equal means the same, that equal means that if you work something out on one side of an equation, it is equal to the other side of the equation. Somebody usually brings up the scale that we have used to talk about what equal means, and that's what I'm going to work with today. So here we have talked about this before. I know that something is equal when it is balanced, when one side is the same as the other side, and when they are not equal, and if they are different, then we would simply use our not equal sign. But we're not going to talk about not equal today. We are talking about equal. Equal is another way of saying equivalent. You can just use the symbol equal for the same thing. Equivalent fractions are two fractions or three fractions that are equal to each other. So when we were talking about our equal, we know that if we have a number on one side, let's just say, we know that 3, 1, 2, 3, is equal to 2 plus 1. They're equal. This kind of is one way of seeing how they're equal. There are a lot of ways I could do that. Now, if I want to keep this being equal, whatever I do to one side, I need to do it to the other side. So I have 3 right here. Let's say I'm going to multiply that times 2. So I'm going to multiply that. I need 2 groups of 3. So there's a group of 3. So in order for it to be equal, I better do the same thing on this side. 3. And once it settles down, you'll see that they continue to be equal. Now, I could add 2 to this side, but I better add 2 to that side. Now, I think I have 8 in there altogether. I could divide this side in half. Let's see, so that means I would take away 1, 2, 3, 4 taken away. I've divided that in half, but I better do the same thing, divide this group in half, and I'm going to take away 4. And I'm still equal. When we were talking about equal fractions or equivalent fractions, the same concept applies. You have to do the same thing to both sides. And when we're talking about a fraction, we're talking about the numerator, the number of pieces we have, over the denominator, which is the total number of pieces there are in one whole. So that's the equality that needs to happen. Let me show you some examples. I have 1/2 right here. And I'm going to talk about 1/2 in terms of this. I have, well, right now I have 1 whole, but I'm going to make this 1/2 right now. This is 1/2. I need to know what is going to be equal to 1/2 if I'm talking about 6. Well, I can go right here and see very obviously that 1/2 is going to equal to 1, 2, 3, 6. They are. I've proven it to you with pictures, but you don't always get to have pictures. So there is a way that mathematicians can use an equation. And the equation is this. What I have essentially done is I have taken 1/2 and I have turned it into 3 times as many pieces. I cut that into 3 more pieces. What I did was I cut it into 3 times as many pieces. Well, I did. But if I do something to one side, I better do it to the other side. Because now I'm talking about this little piece and this little piece and this little piece. And I'm going to compare it to this piece for the whole. And it doesn't match. I have to have them be the same. So if I cut the top into 3 times as many pieces, I better cut the bottom into 3 times as many pieces. And look at that. 1 times 3 equals 3. 2 times 3 equals 6. And 1/2 does equal 3/6. Okay, let's try another one. This time, I'm going to talk about this one. I'm going to say I have the fraction here of 2/3. I have 2 pieces out of a total of 3. And I want to have an equivalent fraction. Well, I have these nice magnets, so I'm going to use them. Okay, I have just proven to you with pictures that 1, 2, 3, 4 out of 6 is the exact same as 2/3. Okay, they're the same. My equation, if I didn't have pictures, would be this. I started with 2/3 and I cut these pieces into twice as many pieces. And if I do that to my numerator, I need to do it to my denominator to be equal. To do one thing to one side that I also do to the other. Two-thirds is equal to 4/6. Instead of looking at the pies, let's look at numbers, number bars. And I'm going to say this. I'm going to start off with 3/4. And I want an equivalent fraction. I want an equal fraction. 1, 2, 3, 4, 5, 6. Okay, it works. What did I do? I cut these so I had twice as many pieces. And if I do something to the numerator, I better do it to the denominator. 3 times 2 is 6, 4 times 2 is 8. I can say that 3/4 is equal to 6/8. Now, I want you to think about this question. Could I do this? One half equals 5/10. I'm picturing it in my mind. I know that I can go up to my other bars or my circles and I can prove it to you. I know I could put it on a number line and I can prove it to you. But I'm going to move away from the pictures right now and just go to the equation. What did I do to 1 to get to 5? And remember, I'm not adding anything in new or taking it away. I have to keep the same amount to be equal. Equal and same. But I know I can take my pieces and I can cut them into smaller pieces to get twice as many or 3 times as many or 4 times as many pieces. I think in this case, I cut 1/2. I cut this guy into 5 times as many pieces. I cut it into 5 times as many pieces. So I'm going to do the same to my denominator. I'd have to do the same to this guy down here. Otherwise, I'm not talking about equal fractions. And 1 times 5 is 5, and 2 times 5 is 10. This works. These are equivalent fractions. So what I want you to see is that this number can change. It doesn't matter what number this is. It doesn't matter at all, as long as I'm doing the same thing to one side that I am doing to the other side. Let's see. I'm going to take this piece and I'm going to cut it into 100 more pieces, 100 times as many pieces. I'm going to do the same thing to my bottom. It doesn't matter because I'm doing the same thing here that I'm doing here. I'm going to have an equivalent fraction. That is going to be 200 over 700. It doesn't matter at all what number, as long as I treat them equally. So they like to write that as an algebra equation. And I know that we've talked about algebra before. You guys did a phenomenal job with it. I think this is going to be easy for you once I explain it if you haven't already gotten it. Since it does not matter what number we multiply the denominator and the numerator by, as long as it is the same, I could use algebra for that instead. I could say 1/2, and if I multiply this times, well, let's use a symbol because we know algebra can either be a letter or a symbol. We just know that it's going to represent a number. We don't know yet. I'll use an eyeball. If I do the same thing to the top that I do to the bottom, I know that I will have an equivalent fraction. They like to give it to you as a letter. 1 times, let's use n for Nico. 1 times n. 2 times n. It doesn't matter what that number is. It is going to give me an equivalent fraction. Right? I can absolutely do that. All right, one last thing to leave you with, so it's not a super long lesson, but I'm going to ask you this question. And I just want you to think about it. If I had 2/3 and I multiply the top, I'm doing the same thing. I'm getting twice as many pieces, and I tell you that that is equal to 4/6. They are equivalent fractions. If I have 4/6, could I do this? This. I have 4. I'm dividing it this time. And I get 2. And I have 6, and I'm dividing it by 2, and I get 3. Am I doing the same thing to the top that I am doing to the bottom? I am. And we've talked about this before, how multiplication and division are related to each other, how they are inverse operations, they can do and undo each other. And if I divided this, I'm not really adding in new pieces, I'm not taking away new pieces, so I'm keeping it equal. And I can. Interesting. But for your work, you're going to focus on multiplying. You're going to focus on breaking it into a certain number times as many pieces. I'm going to leave you with a chain, and then I'm going to sign off. 1/2. I'm going to multiply 1 times 2. So I'm going to take 2 times 2, and I'm going to make a chain. What else is equal to that? I'm going to go to 1, and I'm going to multiply by 3. I'm going to take 2, I'm going to multiply it by 3. I'm going to take 1, and I'm going to multiply it by 4. I'm going to take 2, I'm going to multiply it by 4. I'm going to take 1, I'm going to multiply it by 5. I'm cutting it into 5 times as many pieces. I better do the same thing for my bottom. 2 times 5 is 10. That right here is a chain of equivalent fractions. They are all equal to 1/2. All right. If you have any questions, let me know.